right, so the first part of chapter 2 walks us through the steps of how to create the bin sizes, how to sort the data that we are given into those different bins. And that part is relatively straightforward, easy to follow along with on the book. I encourage you to do so. But then actually linking that data to a PDF, a probability density function, and then conceptually linking that to a cumulative distribution function is kind of an animal of a different sort, right? And so the data that we're given, we're going to put this into a histogram here. A histogram. A histogram is where the class frequencies are marked on the y-axis, the vertical axis, and the classes are marked on the horizontal axis. So we know from the first part of chapter 2 that the first size is going to be 2 to 600, then 600 to 1,000, then 1,000 to 1,400. Then we've got 1,400 to 1,800. We've got 1,800 to 2,200, 2,200 to 2,600. You get the gist. $3,000 to 3.4 thousand, and 3.4 above 3.4 thousand over here. Although this is something that we really don't have any data for, so we're not going to graph it. So we only graph the parts that we have data for, right? It doesn't make sense for us to graph a zero value here, right? I mean, in a way, zero values are graphed for all of the values above whatever the last bin is that has positive values, and also below, right? So this starts at 200, so that means that, if we wanted to, we could kind of insert in here, another bit, right? We could take this and we could move it, and we could say that this part from 0 to 200 has a frequency of 0, right? Now we're not going to do that because it doesn't make sense. We're only going to keep important non-zero information on the graph, right? So we're not going to do that. We're going to put that axis back where it's supposed to be, and then we're going to get rid of all this stuff over here just because it's just cluttering things up. That make sense though? So that's why we're limiting it to just 200 to 3,400. Sorry, this looks like a 6. 3,400. I guess that's not too much better, huh? Delete. 34. Okay. So, in the first part of chapter 2, we find that we have 8 instances where the profit is between $200 and $600. We have 11 instances in the next bracket. We have 23 instances between 1,000 and 1,400. We have 38 instances between 1,400 and 1,800. We have 45 instances between 1,800 and 2,200, right? Seems to be that is the most common. Then we have, above that, we have 32. So we can start to connect these things a little bit. So this is 38, 45, 32. The next one is 19. And the last one is 4. So this tells me that there are 4 instances of profit being above $3,000 but less than $3,400, right? So each class is depicted by a rectangle, and the height of the bar is the number in each particular class. So we can take this thing, Gesundheit, and we can take these points that we have here. We can take the midpoint here, 4 and 8, 811. Let's do a different color. So we take the midpoints of each one of these categories and we link it, and we end up with a, and then in order to do this part, we do have to actually move this. So let's make sure we got all of this stuff, possibly. Oh, I gotta move it more than that. In order to get me to a 0 point over here. Actually, the 0 point starts at 0 frequency, and then it starts at 0 profit. So creating a frequency polygon would be by extending this to include the 0 point and then connecting all of these individual points. Questions on the histogram or the frequency polygon? So the blue, that's a histogram. And the orange is a frequency polygon. Now, when we put a frequency polygon, when we change these axes that we have over here to, instead of frequency, when we change these axes to be the relative frequency instead of the raw frequency, then we end up getting that probability density function. So what we found is for this particular one, right? And so how about, for the moment, what we're going to do, since we already have the numbers here, we're going to take this whole thing away. And then we're going to put a new axis here. And this axis is going to be the relative frequency. And the relative frequency equates to the raw frequency, right? So this number right here in the relative frequency, this is calculated by going 8 divided by the total number. So n is equal to 180. That's the number of observations. And so this relative frequency number here is going to be 0.044. And so we can kind of interpret this by multiplying it by 100 and say that, I mean, well, no, we absolutely can interpret it like this. We multiply by 100 and say that, 4.4% of the total observations are between 200 and 600. So we do the same for all of these values here. So 11 out of 180 gives us 0.061. This gives us 0.128. This one is 0.211. 45 divided by 180 is 1/4. So that's going to be equal to 0.25. And then we're going to have some corresponding amounts here, too, with the 32 corresponding to 0.178, 17.8% are within this category. Nope. Wait, is that 17.8? Hold on, sorry, I got messed up. 23. Oh, that is 12.8. Any questions on this? Is this making sense to everyone? Kind of where we're getting these numbers, why we're putting them where we are, how we're calculating the relative frequency. We're looking at the total observations, and we just take the class frequency and divide by the total observations, right? So this number here is the class frequency. And so this over here is just the class frequency divided by the total number of observations, n. Does that make more sense now? Okay. All right, so this is our probability density function. It is when we're looking at the relative frequency of it, not the raw frequency, and we have things binned in this particular way. So we'll define this more formally later, but this notion right here is, for all intents and purposes, a PDF, probability density function. So how does this relate to the next part?